Don't worry, Instagram folks. Something's going to happen soon. Something magical. Eventually. Boop. Do. Welcome to the desk of Ladyada. I'm hungry for love, and it's feeding time.
What? Hello, welcome to the desk of Ladyada. It's me, Ladyada, and I'm here yet again at my desk and at my computer, and I've been working on all sorts of stuff, and I thought we would kind of continue on some of the themes that we've covered. We talked a lot about capacitive touch recently, and I thought maybe it would be helpful to talk about resistive touch, and when you have resistive touch, when you have capacitive touch, because it comes up sometimes when people are using little displays. So actually have the
But
guide
before
over.
you
Wait,
get
what?
started,
What?
I have a
Okay.
question for you.
Yeah.
What's the difference between resistive touch and capacitive touch? Because sometimes this might be the first time someone's tuning in. In fact, on Periscope it says, this is the first time Bart777 has ever viewed anything on Periscope. So maybe you can explain the differences between the two.
Of course.
Okay.
I would love to. So resistive touch and capacitive touch are two ways of detecting human touch, like whether a person has touched something. And this is handy for when you have like a phone and you touch the screen, or if you have, a appliance and you're pressing buttons on the appliance, or your watch maybe has some sort of a funky interface, or pretty much any electronics
Most
device.
things do now, and that's different than it used to be. Like
Yeah.
TVs, you can like go up to them and touch them and stuff.
Yeah, surfaces. And historically, we've had resistive touch. And the maker market still has a lot of resistive touch devices, although capacitive touch is becoming more popular. But if you remember, like your old Newton, or like if you had an older, what are some old phones that had resistive touch screens? I remember Newton's had them.
Probably any of the pocket
HPACs,
PCs.
yeah.
So there was the
HP,
Jornada, the Cassiopeia,
Yeah.
the iPac.
iPac, that's
Yeah.
it. HP,
Yeah.
whatever.
And there's ones that you need a stylus.
Those were the resistive touch.
Yeah.
Resistive touch, you tended to use a stylus because you got, you would need, well, I'll talk about that, on air, see, it works now. I fixed the on air sign.
Yeah.
Now it needs an OAuth certificate, so I updated my code. I'll show you why you need a stylus. And so we talked about capacitive touch, and the way capacitive touch works is it measures like the capacitance of the human body. We are walking bags of salt water. We have some other like protein.
Semi-digestives.
Yeah, we have like some proteins, we've got a couple fat, but for the most part we are walking bags of salt water. We conduct electricity not so well, but we do conduct it somewhat, which is why you can get electrocuted. We have, we also pick up RF noise through our salt bodies. And so capacitive touch detects the capacitance of our bodies, which is about 20, 50, 100 picofarads or so. And it's a little bit more complicated as a technique. As you've seen, we had to, show how you have to like pulse and measure, and you see the change, and it's very susceptible to noise and fluctuation. The resistive touch is actually a lot easier to use, but it's a little bit more, it's easier to implement as an engineer, but it's more annoying for people. So I'll just show some resistive touch on the overhead so people can tell the difference. And this is how you can tell whether your device has resistive or capacitive touch. So this is a resistive touch display. And the way you can tell is, see, there's like this silver border Like it's dark and gray, and there's a silver border, and also there's like a film, and it's kind of like a matte film on top. It's not super shiny. It's kind of grayish, and then at the bottom you'll see like 4 little silver tabs, one for that. If you actually traced it, it'd go one for each side of the display, and if you have a capacitive touch, it'll look like this. And capacitive touch is much shinier. If you compare it, see how it's really shiny.
One's
and
more matte.
yeah, this is a little bit more matte, and this is shiny. It's glass. It also feels stiffer. Like if you press this, it'll feel squishy. If you press this, it's stiff, and then you don't see any gray. It's usually all black around, and there's not going to be any of those 4 little silver nubs at the bottom.
To relate this to what people probably know really well, and then tomorrow they can be like, cool, my iPhone, Android phone has a
Capacitive touch, almost guaranteed, unless you have a very old device.
That's cool.
Or a very inexpensive device. It's going to be capacitive. This is another resistive one. You can tell again, it's got that silver border and that 4 tabs. And what's interesting about touchscreens is touchscreens are completely separate than the display underneath. So this is a display module, and it has all these connections for the display. And then if you look at the resistive touch, if I get like really close, you'll see these 4 tabs come out here, and then they solder. There's like a separate cable that solders onto this main flex PCB, and these pads come out, and they just go to like the last 4 pins of this connector. They don't actually talk to the display. The display and the touchscreen are completely separate. They don't know about each other. So you can have a display that works without the touchscreen working, and you have a touchscreen that works without the display working. They're completely electrically separate. Now there might be some noise that couples into the touchscreen from the display, but electrically they are considered separate items. And so
Could I perhaps interject a question?
ask a question.
When someone says multi-touch, which I think a lot of people are familiar with, with modern tablets, iPads, iPhones,
Yeah.
Android devices, that seems to be something kind of new. Was the hardware always able to do it? Now the software is catching up, or what's multi-touch in this landscape of capacitive and resistive?
What a great question.
Yeah.
Thank you, floating head of Phil.
I'm not floating.
That's true. You don't really float so much.
I'm made out of love.
You're made of love. Okay.
And wires, apparently.
Love Phil.
Yeah.
Resistive touch can't do multi-touch. It technically can do 2 touches, but not very well. And I'll show how resistive touch works. Capacitive touch can do multi-point. Capacitive touch has the ability, because each sensing is done separately, whereas with resistive, you could only measure 1 point. Because the capacitive touch, it's this grid, right? Like when we showed before, you could have a single point capacitive, but like imagine you had a grid of like 50 by 50 of these sensors. You can measure the points in between. You can actually track as many points as you want, although more than 10, I think, when would you ever have more than 10 points? I don't know. Usually, capacitive touch, the cheap controllers can do 1 point, and then some of them can do 2 or 3 or 4, and then like the really nice ones can do 10. But honestly, people don't tend to use more than 2 or maybe 3 points. You pinch and zoom, kind of the only thing. So
Yeah.
I'm a little iffy on like whether 10 point is required, but some capacitive controllers use 10 point.
Since you're an engineer and you look at lots of electronics, have you ever seen a multi-touch resistive where you had to use like 2 pens or something like that? Have you ever?
No, you don't use 2. You don't use 2 pens. Again, the math works out. You can do it, but you lose. It's tough to get good quality.
Yeah.
So people tend not to do it, and you have to. It's like you have to kind of keep track of what's going on.
Mm.
So maybe I'll show how resistive touch works, because resistive touch is very interesting.
Right. And
Right.
the title of tonight's Desk of Ladyada is FUNdaMENTAL. You're fun. I'm demental. And this is Monday, and this is all about resistive touch. Oh,
Yeah.
look.
The whiteboard.
Yeah.
That's
oh, you
the
know
one.
what? Every time, yeah.
Wow.
Woo.
Okay. Well, whatever.
Yeah.
That's fun.
I wasn't expecting that.
Whatever. It's cool.
You could tell this is live.
It's all live.
Yeah.
Oh, because it's like there's this.
Yeah, because there's a shadow.
There's a shadow right there.
Yeah. I don't know. Maybe turn that light. No, turn that light off.
Turn it off.
Yeah. Well, that made
That's
it worse.
cool.
That totally made it worse.
Yeah.
Although, what's interesting is when you do that, it gets rid of the background so people could focus on it more.
Yeah.
Anywho,
We have to experiment more.
we have a tiny apartment. I don't have any more room.
Whatever. We're going to look at the whiteboard anyways.
Yeah.
Okay. So what's interesting about resistive touch is if you remember, if you've ever used a potentiometer, you connect it to like one side to power and one side to ground, and then you have the wiper, which is in the center. And when the wiper is all the way down here, you get 0 volts. And when the wiper is all the way up here, you get, let's say this is 5 volts and this is ground. So this would be 5 volts. And then in between here, it's like 0 to, not 2.5, 0 to 5. As you twist the knob, it moves up and down because you're moving along this resistive element here. And if you ever opened up a potentiometer, which you should totally do because they're really fun, you'll actually see something like this. It's kind of like this, kind of like the open source logo.
Matthew in the chat pointed out that resistive touch can sometimes be useful since it can detect pressure.
Yeah, it's true. I'll show how you do that.
Yeah.
So let's say, this is actually what a resistor looks like on the inside. There's this gray resistive material. That's what it's called, resistive material. And then the wiper is actually like a little contact, and it wipes between the 0 volt contact down here and the 5 volt contact. So when you twist the knob, actually technically the thing is here. When you twist this knob backwards and forwards, you're touching the resistive material. And they pick the resistive material so it's like 10 kiloohms per inch. Right, and so this is 1 inch total length, and so as you wipe along it, you'll get different resistances. The resistance will change from 0 to 10K, and of course you can get 1K per inch resistance, and then of course you'll get a smaller resistor, or you can have 1 mega ohm per inch, and then you'll have a really big resistor. And then if you have a really old stereo, sometimes it gets really scratchy because the wiper scratches away that resistive material. What's up?
Okay, so when you see somewhat new technologies, they might be not so new for you, Ladyada engineer, but when Apple recently released the Force Touch, so when you press down on the screen and it kind of does a little thump back, or when you press and hold and something happens, it's in addition to multi-touch and everything. How does that work?
That's totally done in software. So they have a little a vibration motor, and the capacitive touch. I mean, the
it's
screen
tricking
is,
you.
The screen is hard. Like
Yeah.
there is no. You can do a little bit of pressure sensing with capacitive touch by detecting how big of the touch spot is.
Yeah.
Like the more you press, the bigger the spot. So it can kind of, if you have really big fingers, it'll think it's higher pressure.
So for iOS, the software is detecting a press and hold, and it's using a little, like, one of those little pager, I think that's what people are familiar with, little pager motor,
motors.
and it makes it feel like a thumb.
It goes like a thump. We
like a
actually
haptic, like a haptic.
We have them in the store. Yeah, they're called haptic motor drivers.
Yeah, that's cool.
And it's really neat. Like with different ways of buzzing the motor, it feels like it's doing something like the Kindle I have does the same thing. When you press the button, there's a haptic control that makes you, it gives you feedback that the button press was received. Because that's the problem with capacitive touch is it's so hard, you don't know whether you pressed it.
So a good example would be some of the people who made haptic belts, where it'll kind of tap you or feel like it's tapping you based on what direction you're walking.
Yeah, you can do accessibility stuff with it. I mean, it's usually done for interfaces, especially when it's a touch screen that doesn't have a lot of good feedback. They'll use touch feedback. 'Cause you respond. I mean, also game controllers have haptic feedback.
Okay. And then something like the iPad Pro that uses a stylus, and it has, you could touch it with your fingers. What's going on there?
I don't actually know that much about styluses, the way they work with capacitive touch, but it could be, there is a little bit of electronics in there that emits a small RF radiation, or it can adjust the capacitance. Like, you can have a voltage controlled capacitance somehow that tricks the touchscreen into thinking that this stylus, which is not conductive, is capacitive. But I don't, because there's an electric field, right? I don't know exactly the details of how that works.
We have an iPad Pro for testing, and I have to pair it. So it's definitely doing something. It's aware of its battery level.
If it's paired, then it could be Bluetooth, but it's still doing something. I mean, it could be either. It's tough to know. Like, I mean, I've never taken apart one of these styluses. Either it tricks the touchscreen, or the touchscreen communicates to the stylus and tells it where it is.
My suggestion would be exactly what we would do. Good iFixit and see what was torn down, and then you could see the chips, and then you'd be able to tell what are the things going on inside of that pen.
Yeah, resistive touch styluses are just plastic. Capacitive touch styluses are funky. Okay, so we saw the potentiometer. So if you don't understand how potentiometer works, right, you've got 0 volts at one end, 5 volts at the other, and as you wipe across this conductive material, you're going from 0 to 5 volts. That's actually pretty much how. Just imagine instead of a resistor being linear, it's a sheet, right? So if you have a sheet of resistive material, and it's resistive in all directions, right? It's a sheet resistance, and then you have another sheet right below it. This is the resistive touch screen. This is basically what's going on here. And then you have one contact here, and then one contact here. We're going to call this like X minus, and this is called like X plus. And then there's a contact over here, and this is Y plus. And there's a contact over here called Y minus. And that's pretty much what's going on. So if you actually look at, and we can maybe someday look at the resistive touch screen under the microscope, you'll see there's like little dots of silver. There's a it's conductive material. So I think ITO with some conductive material.
Yeah, we have ITO in the store, and maybe we'll do that. We'll take apart something and put it under a microscope.
It's a film, and the thing is, the one thing you have to watch out for is because there's a film, it can wear out. Resistive touch can wear out. It takes a really long time for it to wear out, but if you press too hard, you can wear it out. And from what I remember, I think this bottom sheet is glass, and this one is plastic. I think the bottom one is hard, and the top one is flexible. And then when you have a stylus here, and it comes down onto the sheet, what it does is it creates a little dent, and the dent touches the bottom sheet. So this is like way farther apart than they should be.
Yeah.
I'll extend this over here. So if you have this sheet here and you press down, it actually goes down and touches the glass part. And so the resistance here, like you basically get a short between the plastic and the glass. And it's a little tough to think about, but if you're thinking, okay, well, they've got this resistive part on top, and you've got this resistive part on the bottom, what happens when you press down with the stylus and you make a contact between the two, then if you have 0 volts over here and 5 volts over here, then at this point, you can measure that off of this sheet because you've made basically you've made a wiper. You've pressed down onto that sheet, and now you can measure the resistance off of here.
Okay. As someone pointed out in the chat, ScanLime's YouTube channel, which I just posted up in the YouTube chat, has a great, overview, experimentation, hacking of tablet stylus stuff.
Yeah.
Yeah, so check that out.
I just don't know whether, I think she made it do other things. I don't know.
Yeah, of course. That's the whole point of that channel.
I don't know if it
electronics that are doing something that they probably weren't supposed to do.
Yeah.
Welcome to ScanLime.
So this is how it works. You have two sheets. The glass sheet is stiff, flexible sheet. You press down, you make them touch together.
Okay, so a question.
Yeah.
So it's like a joystick, but the potentiometer changes resistance by touch?
It's more like a potentiometer where you only, normally you just turn the knob. If you have to press the knob down to make contact with that resistive band, and then you could twist. So you have to, when you press down on it, like normally you have, you have like the wiper, and it's always contacting. But what if you look at it from like the side, you have this sheet, and then this is the wiper, it's this contact, and so this is 0 volts, and this is 5 volts, and you have this contact here, and then this is, this is one very big long resistor. If you had to physically press down on this, and then it would touch the resistance. So normally this is actually floating, and then when you press down, it makes contact with this resistive material. And that's it's basically how it works. It's just it's basically a potentiometer, except it's an XY potentiometer, and you have to press down to make contact with the resistive material.
Here's a question. Didn't the old ones have issues with the film getting deformed? It wouldn't come back after using it for a while?
Yeah, if you have resistive touch now isn't a problem, and if you don't press too hard, it isn't a problem. But yeah, if you press down, you'll dent that soft plastic upper layer so much that it makes permanent contact, and then it doesn't lift.
Okay, I'm
Because
learning.
it has to be springy.
I'm learning lots here tonight.
Yeah. Okay, so do you want to go to the demo?
Yeah.
Okay, so let's go to the demo.
I'm here for the demos.
Okay, so this is a resistive touch here. You can see I've got it working. I've got it hooked up to a feather, and this is my 3.5-inch TFT. But again, remember that the screen is separated from the touch. So now that you've seen, okay, it does actually work. Let's actually zoom in and look at the X, Y, and Z for the touch screen. So what I'll actually do is I'll disconnect the touch screen altogether. So I'm going to remove the touch screen wires, and I'll hook them up again. So I'm going to remove these. So the touch screen just got totally wigged out. 'Cause it's hey, why did you disconnect?
Don't do that to me.
Don't do that to me. That's okay. And then actually I need some power and ground wires. Probably should have grabbed some. Uh-oh.
While you do that, I have a Sparky video.
Okay. Go for it.
If you want to see me, Sparky the Blue Smoke Monster, put your electrolytic capacitor in backwards. And don't do it, but if you do, it's not a big deal. You could just, start over. It's okay. Alright.
Okay. All right. So
There's our commercial break.
So I've zoomed in.
Desk
Okay.
of Ladyada brought to you by Sparky brand smoke. When you want blue smoke, only accept the best.
The
Sparky
smokiest.
brand
Okay.
blue smoke.
So down here I've got if you see carefully, it says Y plus, X minus, Y minus, X minus. So these 4 are the resistive touch pins. So let's just measure one direction. So let's maybe measure the Y direction. So what you'll do is you start by connecting Y minus to ground, and then connect X minus to ground and X plus to positive, which in this case is 3.3 volts. And then we'll use our oscilloscope lead.
Man, it's only Monday and the scope cam is in effect.
Yeah, so we'll connect the oscilloscope to Y plus. So now, hold on.
Buy some electronics. This oscilloscope is 14 feet tall. It takes a lot of power, everyone.
Okay, so let me turn off blue. Okay, so this is my floating Y. So when I touch it, it floats. There's nothing connected to it. I have my finger on the probe. You'll see I'm picking up noise, so that I know it's not being driven. But when I press my finger on the contact, you see it moves up and down from minimum to maximum. Can you just go to the overhead real fast so you can see? So this is me moving it back and forth.
Okay, so we're moving back and forth.
Yeah.
And then we're going to
moving.
go to scope cam.
Back and forth, up and down.
Back and forth, up and down.
So it's
up and
pretty
down.
easy. You're just getting an analog voltage.
Back and forth, up and
Okay,
down.
so then I want to show what happens if I move my finger up and down this way.
Now you're going up and down. Let's see
Yeah.
what's going on with that scope.
So you see nothing. It's not moving because you're only reading one axis at a time. Right? So now if I want to read the other axis, so go to the overhead, I'm going to swap the wires. So instead of having ground connect to X minus, I'm going to have ground connect to Y minus, and then power, instead of connecting to X plus, can connect to Y plus. And then I'm going to read the voltage on the X plus line.
Yeah.
Okay, so now I'm here. So now when I move my finger back and forth this way,
I wrote that way.
not a lot happens.
Nope.
But when I move my finger up and down,
Oh, look at that.
can you go to the...
Yeah, I'm going to just switch
This
back
is,
and forth.
yeah, it's this
Up
way.
and down.
Up and down, left and right.
Up and down.
So you can see you can only use
a
two
fun video
pins.
game.
You set the X minus to 0, X plus to positive, and then you measure the Y pin as it touches. And then likewise, when you want to measure the other direction, you set the top and bottom pads. So remember I showed you that silver outline, these silver outlines?
Yeah.
Right, this is X minus, and this is Y minus, and this is Y plus, and this is X plus. So you have, minus and plus for X and Y, X and Y. So minus, plus, you can measure up and, up this way. And then if you set these two, you can measure this way. So these are the two options you've got for measuring.
Beep, 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 beep.
And so you need 4 pins, and 2 of them have to be analog pins. And that's kind of the downside. If you don't have a microcontroller with analog input, you're going to be kind of bumming. You need to have a resistive touch controller. So there's chips that you can buy that kind of do this all for you, and they have analog pins and they convert to I2C.
Yeah.
So the next thing I thought maybe we would, I would hook up back the controller as it was,
All right.
and then I would reset the micro, and we could
Out of
be pro.
the products that you have created, Engineer Ladyada, what's your favorite screen in the Adafruit store that does some of this stuff?
I like the 2.8-inch resistive. Yeah, it's classic. It's a classic screen.
All right.
All right, so let's hook up X, and then I'm going to also hook up Y. And you'll see that, let's go to the oscilloscope.
Yep.
So you'll see it's a little noisy. Hold on. What am I triggering on? There you go.
Someone said you could put the scope in XY mode.
That's not going to do what you think, because remember, I'm reading analog voltages, but then they turn into digital, so it's going to make a weird mess when it's in between. So you see here, it's not always, it's got logical voltages that it's doing. So when this is a little bit tough to trigger. Maybe, hold on. I'll trigger on the top. Ooh, this is not fun to trigger on. Okay, that's not so bad. So you can see here, as I move my finger, see how there's this nub, and then there's this nub. So this nub right here, that's the Y reading, and you can see nothing's really happening down here. And then when I move my finger the other way, so I'm going this way and then I'm going this way. So when I'm measuring one axis, the nub doesn't move, and then when I move the other way, the bottom. So if I go the x-axis, the blue nub moves up and down, and when I do the y-axis, the yellow one moves up and down. So what it's doing is, you can see it's setting this pin high, and then measuring the analog voltage, and then it sets this pin high, and it measures the analog voltage on the other one. And then this is, if I move my finger in a circle, you'll see how the pins are sometimes fixed and sometimes analog reading. What's up?
So how do you do the 2 touches? Do you just measure it really fast? How do you do that?
When you do 2 touches, it's been a while since I remember I looked into it. Basically what you do is, if you know the resistance of the screen, then if you have 2 touches and you can measure the resistance, you know how far apart they are, because you know you must be shorting. Like you would read the total. If you're touching twice, I don't have code for it, but I remember I once like got it working. If you know, I'll just demonstrate it with like a normal resistor, and then you can imagine how it would be in a plane. If you set this to 0 volts and this to 5 volts, and you know that this resistance is 1 kilo ohm, then if you have 2 touch points, these will actually be shorted together, like the 2 touches. They end up being shorted together, but because of them being shorted, you can measure. That was like the worst. There you go. You can measure this resistance, and then you can measure this resistance, and that will give you this resistance, and so you know how far apart they are on, like, you know, the x-axis. But you need to know this resistance, and you have to be able to do pretty precise resistance measurements. Like, it's not super fun to do, but you can do it. But you have to be a little bit trickier about, like, I think like you need to let this float, and then you can measure this resistance, and then you measure this resistance, and then you, like, I don't know.
That's tomorrow's show. Not super fun.
I remember doing it, but you can imagine, like, you can do it with 3 points, because with 3 points there's not enough equations to solve, but with 2 points there is. But you have to know that resistance, and you have to be able to guarantee it. And the thing is, there is variation from screen to screen. So this resistance, you can usually tell what resistance your you can get specs for the resistance of your panel. Usually it's like 500 ohms by 1 kilo ohm resistance from point to point, but it's not guaranteed. It can vary. And so if you try to do 2-point touch with this technique, you'll have frustration because it'll be imprecise. You'd have to do some serious calibration per screen. Whereas single touch, you can kind of get away with not calibrating per screen. It's usually pretty close, as long as you know. As long as you have pretty good analog reads, because again, the resistance falls out of the equation. You're just measuring between 0 and 5 volts. It doesn't really matter what this resistance is for single touch.
Yeah.
Yeah. So I don't know if people want to see more.
That was
resistive
helpful.
touch.
Do you want some general questions, or do you
Yeah,
want?
sure.
Okay. All right. Let's. I don't know.
Well,
That's back.
hey, now we're back.
Anywho, yeah, internet. So we're back.
Yeah.
Here's a general question from the chat. Let me just see if we're actually back.
We have a lot of hearts.
Yeah, just hit refresh. I think YouTube hiccuped. Anywho, so generally speaking, if someone wants to get a chip but it's under NDA, do you have any strategies on getting that chip without signing NDA?
Yeah.
I mean, any ones you can talk about.
in a legit, well, there's not a lot of legit ways to do it, but the first one, of course, is just Google it. You never know. There's a lot of data sheets that just end up on the internet.
Maybe DuckDuckGo.
Yeah, use different internet browsers. Sometimes they leak. Another thing you can do is go to Chinese sites that do data sheet trading, or if you search on Baidu, that'll search like the Chinese internet. Chinese engineers don't really believe in NDAs. They pretty much send anything around and will post onto forums. You might need to install translation software if you don't read Mandarin, which I don't.
Yeah.
So I have a translation software. I also go to a site called PUDN.com. And you do have to pay, or you have to upload. It's like an old Ware site where you have to like get credits. But they post NDA stuff all the time, and like source code for chipsets. Like, it's very Chinese oriented, so you're not going to get like the latest chip. Like, if it's a new chip, it's not going to be there. But if it's a classic chip that just happens to be under an NDA, It might be there. Also, some chips that were under NDA are eventually they come out of NDA. Like all the Broadcom chips are now on Cypress's website. Cypress bought Broadcom, the IoT stuff. So all their Wi-Fi chipsets are fully documented now. Like, because
Yeah.
Cypress doesn't really do the Broadcom NDA thing. But that's kind of my best bet. I found a lot of stuff on like the Chinese internet engineering websites. You have to dig around a little bit. Also, like Russian forums, they don't have a problem posting it either.
Yeah. The 5-point palm exploding heart technique is not real. Next up. Okay. Someone's asking, I think they have a couple. Here we go. Can you explain the cobbler? The person is asking, can you use that instead of the GPIO pins with the cable thing? What's the cobbler do?
It just makes it easier to plug it into a breadboard.
Yeah.
Like I have
Why don't you go to your computer? Oh, you have one right
I have
here.
one right here.
Look at that. It's
an
as
older
if you
one.
knew.
Well, this is an older one, so it's a smaller
Okay.
one. But basically, if you have your...
So do you use it instead of or with the GPIO?
You use it with, usually you have like a cable.
Okay.
And this is like, I don't want close up. Normally you'd have a cable that plugs in from here to here.
Yeah.
And it just makes it easier to use a breadboard. It's just annoying to get cables, little wires that plug in here. Another thing is they're not labeled.
Yeah, it never
And
works out.
there's 40 of them. It's really easy to mix up, connect to the wrong one.
Yeah, I'll
With
try to
these, they're all
focus
labeled.
that down a little bit.
It's not
Beep,
focused.
boop. No, it is.
Okay. It's easier because there's like writing on each pin. It just makes it a little easier to plug it in. And then you don't have to get into these individual pins with wire. I mean, you can plug in individual wires.
Yeah, like the chat said, it's an extender, plugs in the breadboard, super
It's
handy.
an extender. It makes it easier to do breadboard
Yeah.
projects,
Um,
especially with the 40-pin connector. Like,
Yeah.
I don't think beginners can count down and get the right pins.
all right.
Come
Well,
from.
I'll answer. There's a follow-up about the NDA stuff. Is it worth signing NDA? Well, here's what I'll say, because I'm going to do a little bit of maker biz tonight, so I guess I got to go to me.
Yeah.
Is it worth signing an NDA? Sometimes we have to say to a supplier, we can't use this chip that your salespeople keep bugging us about because we don't want to sign an NDA because we do open source, and it'll be a giant pain later when everyone asks us, can we see the source code? Can we modify? Can we use it in our projects? Can we use it for commercial use? So for us, it's almost never worth it. There's certain times, weirdo stuff like wireless, it seems like sometimes you have to, but generally speaking, you have to weigh your goals with your business. We're open source hardware and software, and we like to share with what you want to get done. If you're doing a product and it's just for you, maybe you don't care. But one of the things you can do is negotiate with NDAs. Often if we get one, it'll have something insane like 5 years. Like 5 years when we were in an apartment. It doesn't make sense to sign it. Like, where are we going to be in 5 years? Probably Mars. So you can ask for another time period too.
Yeah.
Like chips have a pretty fast metabolism as far as how the market works. You can ask for a 3 month, 6 month, 9 month.
Yeah.
If they say no, then like, why? What's the reason?
Another thing I've noticed is all the chips, there have been some chips that I've signed NDAs for. Not always, but in general, if I'm signing an NDA for a chip, the support on it's going to be really, really bad. Like, you're not going to get almost any support.
Yeah, because you can't tell anybody how bad it is.
Because, it's one of those things.
But
it's
you
like,
can't talk about
if
our bad
it's
support.
under NDA, they basically will not talk to you. They won't support
Yeah.
you. They won't help you. You're kind of screwed and you're on your own. So unless it's unless it's like the ultimate chip and you absolutely have to use it, I'll pay more for a non-NDA one because I know I'll probably be able to get it working better than if it's an under NDA one. Because there's usually like if there's an issue and I Google for it, like somebody might have already solved it. People have already written drivers for it. Use an NDA chip. You're not going to. You're like not going to be able to find
The market's
anything.
changing quite a bit too. We used to get told we had to sign an NDA all the time, and we would decline and just go do something else. Now, chip companies really want this maker market because it leads to the larger business-to-business market, or people who buy tens of thousands of chips. So they
I'll
generally.
tell you something I've done actually. By the way, just reminded me because I was thinking of a gyro that I really liked from Maxim. I ended up not using it, but the chip was under NDA, but the eval board was not. And so you could get the eval board, and it came with evaluation software.
So you pay a little more, but
So I would pay $60. I got the eval board, and then I sniffed the I2C connection, and the eval board let you like set all the settings, and so you could basically extract the register map very easily by like changing. You would just change one bit at a time, and you would just see what register it changed. And so even though there wasn't strictly a data sheet that was available, it was like some Maxim gyro with like built-in quaternion or something. It was really, it ended up not using the chip, but it turned out like for weird reasons that you could get the eval kit. And so the eval kit made it so you didn't really need a data sheet for basic usage. So that's a weird hack. It's rare though that happens, but sometimes you never know.
Okay. Is that your Fundamental Monday?
That's my Fundamental Monday.
All right, we're going to do Sparky, and then we're going to come back. I have a little maker business tip since we're talking about maker businessy stuff.
Okay.
So let's go to Sparky.
All right, you got two choices. You can see me or read the data sheet.
All right, can you hand me the envelope?
Here's the envelope.
Exciting. Okay, so
And the winner is...
No, so what this is spam garbage that we get in the mail, and this is from GLOPAT, Global Patents and Trademarks, and this is pretty much a scam. I'm out of focus, but it's okay. I X'd out the trademark. But what happens is in the U.S. when you register a trademark, it seems like there are...
You're fuzzy and lovable.
yeah, I'm going super fuzzy.
This is so cool.
Woo! That's cool.
All
Anywho, back to the overhead.
Hey! You want to show this?
Yeah, so I'll tell you what happens is when you get a trademark, you get these kind of scams in the mail, and they're invoices. And
What's great is that this is from like Hungary.
yeah, they're invoices, and they're like, look, you owe us $2,800 if you want to keep your trademark registered, and you just get these all the time.
Yeah, we get like 6 of these a week.
And one of the things that you should do if you're a U.S. company and you have a name like we do, Adafruit, you should register your trademark. An example of a time where a trademark wasn't registered properly worldwide was Arduino, and that caused a split of the company. There was two Arduinos for a while, and there was multiple companies operating as Arduino around the world. And so what this is a scam that you get physical letters and say, pay this. And if you have a big company, it pretty much probably works. They just need like a few people to send them $2,800. And it's for a trademark in another country. And if you read it, it's like, this isn't even
This
legal.
has nothing to do
This
with
has nothing to do with
anything.
anything. And
Yeah.
you just get these constantly. So
And sometimes, they'll put them in letters that, this one is at least like somewhat
Yeah.
honest in the fact that it's like global, it's not American, but sometimes you'll get ones that look like they're on like federal letterhead.
yeah,
You know, they'll-
domain names, the same
Yeah.
scam. You'll get something that says renew your name, and like, why am I?
USPTO.gov.FQ
Yeah.
or something. It'll be something.
Compliance posters, all these things. So one of the things is make sure that you have someone who's checking the mail before it gets to your accounting, bookkeeping, invoicing, and just read it over. And it is a good idea if you have a U.S. company to register a trademark. Just know that once you do that, there seems to be a flood of these things from around the world saying, "Give us $3,000. We're in
Yeah.
Budapest." For your
This one is actually in
trademark."
they're in Budapest, but the company is in Bratislava.
Who knows? And the letters, it's bulk mail, so who even know where it comes
Yeah.
from? So,
It's a total scam. We get dozens and dozens. Every time we register a trademark,
Yeah.
we get more.
So when you do open source hardware and open source software like we do, and you give away the code and the schematics and the hardware, the only thing we really have is our name, so we care about that stuff. But even with that, you still are susceptible to someone trying to completely roll you. So, watch out for. We haven't got burnt, but it's only because we're kind of paranoid. So,
Yeah.
yeah. All right.
Great scam though.
Yeah. Good try. GLOPAT. Anywho, am I still blurry? Look at this. I don't know why it's doing that tonight. Woo.
It's cool. Hey, there you
There
go.
you go. I'm back. Woo. Okay.
Now you're- wait, you're blurry again.
Why am I getting where? That's cool. It's like a Connect or something like that. Anywho, happy Valentine's Eve, everyone. It's almost Valentine's Day
Okay.
in like 30 minutes.
Ooh.
Yeah,
Lovely.
yeah. You know what tonight's wisdom is?
What's the
Before we go?
wisdom? Yeah.
Like, you always hear this quote like, love yourself before you love other people. No, that's wrong. You know what? Try caring about others and being others focused, and you'll probably feel better about yourself. And then you could probably get love.
Yeah.
Yeah, if you want love, you have to give love. And this whole idea that, like, be a selfish jerk.
The love you make.
Yeah,
is
be a
better than
selfish
the love
jerk,
you
then you
take.
can love others. Well, maybe
Okay.
go the other way for a little bit.
Okay.
Yeah,
Try both.
yeah. Yeah, see what happens.
See.
Experiment. So that's tonight's wisdom.
Thank you for that wisdom. I hope we learned a lot about resistive touch. Check out the touchscreen library that we have in GitHub. It's under the Adafruit repos. It's called Touchscreen. And you can see the code. It's very simple. Pin high, pin low, analog read, swap them. Analog read gives you X and Y values.
Yeah.
Works with any touchscreen. Have some example code. I just updated it today to make it work on all the latest Cortex M0 chips that we are carrying. Good stuff.
Okay.
Okay,
Thanks, everybody.
so we don't see you tomorrow.
Yeah, we'll probably do broadcast. We'll see.
Maybe. If not, Wednesday.
Yeah, Wednesday,
Wednesday.
7:30 Eastern is show and tell. 8 p.m. Ask an Engineer. And we filmed a bunch of Sparky, so you'll see Sparky all throughout the week. All right, that's it, everybody. Later.